Hi everyone, today we will introduce a new technique for solving very large linear programs. So last time we have used the simplex algorithms. This is also related to the simplex algorithm that we have covered last week, but it will be for solving very large simplex algorithms that you cannot even think about fitting it in memory. This is called column generation. And to introduce the concept of this technique, we will use a problem that is called the cutting stock problem. Okay, in this problem you are given a set of planks of woods that are represented here, and they all have the same length, right? And the length of the plank here is the capital W. Okay, that's the length of the plank. And you have to cut a set of orders that are given in advance, so that you minimize the total amount of waste that you will have by selecting the number of planks that you will take there. Okay, so for instance, you have here 3 orders represented by the colors. You must cut 3 orders of length W1, 2 green orders of length W2, and 4 here pink orders of length W3. Okay, and you need to decide how to place the order and select the right number of planks here of size capital W, so that you minimize the amount of waste. This is, for instance, one possible solution. Okay, you can see that in this solution I have correctly placed 3 reds, 4 pinks, and 2 green orders, and this is the total amount of waste that you will have. Okay, these remaining planks here that you have that are represented in brown, so the original color of the planks, is not used to produce any order, so this is a waste, and this is what you want to minimize. You want to minimize the amount of waste, and you want to decide how to assign the orders to the plank that you have selected. So that's the problem that we want to solve here. Let's design a first linear program for solving that problem. And the linear program that I will have is, and it will be an integer linear program in that case, is to introduce one binary variable here, wj, to decide if I select a plank j, yes or not, to be part of the solution. Okay, so I will introduce one w for each of them, and I assume here that I have enough planks at the beginning, so I have one binary variable just to decide if I will use it or not. Then I will introduce one variable for each order type to represent the number of shelves of type wi that I will assign to plank j. Okay, so for instance here you see that I have selected 2 red orders, and I will assign them to this plank 1, so x11 is equal to 2, to say that I will produce 2 red orders out of the plank 1, and here x31 will be equal to 3 because I will produce 3 pink orders using this plank 1. Okay, and so on. So these are the decision variables of my model, and this is I will introduce now the equations to be sure that we correct all the orders that you wanted to satisfy, and also that we minimize the total amount of waste. So minimizing the total amount of waste, since all the planks have the same length, it's quite easy. You just want to minimize the total number of planks that you will use, so you minimize the sum of yj's. Okay, yj variables. You minimize the total number of planks that you will use. This constraint will make sure that if you assign any order, at least one order to a plank j, then this plank should be selected. And m is a value that is large enough. Okay, let's assume that it is, for instance, plus infinity, but in practice you don't put plus infinity, you put a large enough value here, large enough constant to big M. This is why it's also called a big M model, or big M constraint. Okay, and it will make sure that you have no other choice to put yj to 1 if at least one of the planks here is assigned to j. At least one of the order is assigned to j. If at least one of them is assigned to j, then to make sure that this inequality is satisfied, okay, then you need to put yj to at least 1. okay? And so since it's a binary variable, it will be 1 in practice. Then, of course, because you want to minimize the total amount of planks here, you need to make sure that you do not exceed the capacity of the plank, okay, which is limited to W, capital W, which is the length of the plank, okay? So capital W is the length of the brown planks. And so the total amount of length of orders that you assign to this plank J should be less than W, and this should be true for all the planks. Okay, and of course you need to satisfy the orders that are specified. Okay, at least 3 reds, at least 2 green, and here at least 4 pinks. So you have that the sum over J of xij should be larger than bi. Okay, bi is the amount of orders of type I, and so the total amount of orders of type I that you will assign should be larger or equal to bi to make sure that you satisfy all the orders. So that's an integer linear program here. It's an integer linear program because this is a binary variable and this is also an integer variable. Okay, so this is an integer linear program for solving my cutting stock problem. In the next video, I will explain the weaknesses of this model, because in practice, although it's a simple model, there are some strong weaknesses that comes with this very simple model.